Again, this is a very brief introduction to 5G core.
Hey, can you increase your volume?
Is
This better?
Yeah.
Yeah, okay.
So
introduce software networking and 5G core. Again, we already got schedule on the very basics, SDN. Go to presentation mode. There we go. And here's the basics of software-defined networking. You have 3 planes of traditional networking. One, the management. Second, the control plane. Third, the routers. Was the control plane, which is basically the routers managing OSPF relationships. And then you have the forwarding. Management you can view as basically your GUI or terminal client for Cisco. Now, a software-defined networking provides benefits, especially for larger enterprise networks, especially networks such as 5G cores, data centers. Again, centralized management, but centralized managed by extracting the control plane from the data plane, which then allows discrete networking devices, and abstraction. The control plane enables centralized management of the network devices, providing APIs. With SDN, you have both the northbound, southbound APIs, which I will go over. Sorry, I got cut off in the recording on that page. We're having Okay, yeah. Okay, everyone over to 3-place traditional networking. And that fits. Sorry, there was a little instrument prompt on the note, but. Issues. And as you mentioned with the APIs, software-defined networking, you have the application layer, which are the northbound. So you have your business applications, you have bridge to the control software, network services. Then south, you have all the network devices, routers, switches. So again, the very basic view. It gets much more complex, especially once you get to 5G cores, which I will show. And of course, common devices. We have mobile network cores. Example for this home lab, which is using Open5GS. We also have the major mobile network carriers, AT&T, Verizon, T-Mobile. They have each have their own 5G core as well as previously their own 4G core, which is also very great example of 5G. Software networking. Go over this Open5GS very briefly to this, where we are with this home lab. And SDN is also used for data center network management. Of course, data center you have many servers. And looks over there. More cases and enterprises. And of course, SD-WAN. For example, you have a large retail bank. You have many branches, each branch measuring all those devices. That's where SD-WAN, software-defined wide area network, comes into play, which is a subset of software-defined networking. Again, software-defined wide area network, very useful for multi-site connectivity. Welcome. Begins up. Starting over again. Software-defined WAN. Multi-site connectivity, branch office to essential network. As mentioned, example, you have your major bank branch, and lots of branches throughout the country. Useful there. And for Open5GS, which is again one of the very popular open source 5G network cores. There are a few others. I'll briefly describe those too. Find it here, and this is again where network engineering and software development come into play, as you can see. Open5GS specifically is written in C. There's another implementation, I can't remember the name off the top of my head at the moment, that's written in actually Golang. It's another open source project core, but let's first go to now the blog post page I have, so let me, I'm going to now jump over to another page. And this personal right up here. Again, as mentioned earlier in this meeting, we're getting familiar with SDN. That's how to expand it with Open5GS. I have to get it running mostly running on USRB 8210. Now, if you get these new, they can be quite pricey. If you end up looking out on eBay or Facebook Marketplace, you might get a deal. And as you can see, here's the radio I have set up to power it on. What I'm going to use for. Oh, yes, sir.
Yeah, if you're sharing, I can't see, or if you're showing something. Sorry.
Issue here. Sorry about this. Bring that up. There we go. Now I should see this. Okay, again, that's a quick introduction I wrote on Project Core. And this is again, as mentioned earlier, to get a better understanding of software-defined networking, especially how it relates to telecom, telecom. If you're in the DFW area, telecom is very big. We have actual headquarters at AT&T in downtown Dallas, regional headquarters for both Verizon as well as T-Mobile here as well. And if you're in, like I said, software engineering, software side, this is software-defined networking is basically the intersection of software engineering and network engineering. I feel that tech is always constant learning. Yeah. And again, it's basically tore out filed. And again, here's the radio I have set up. And other fun fact with this project is it does allow you to use mock SIM cards. Very similar to your off smart cards or CACs if you're in the DoD space or federal space, which they're referred to. Just we're also seeing them start to be rolled out into private enterprise, especially finance. Finally getting those. So the basic setup of programming them or reading for data from them is actually the same kind of reader. But yeah. So I'm gonna link this in the thing, but yeah. And I'm gonna check now. Any questions so far? So continue on. Okay, here is where I've been starting so far. Basically, great way to learn film routing, as mentioned. Very happy to see I get a couple of people here, both using Proxmox for film routing. Great place. Once again, just going through some tutorials. And as you can see here, I have the Linux system set up, which I'm going to jump to. And we have a okay. So now I'm going to jump over to this one. And I'm going to show you where we are with the Linux machine. Share my screen from here. Okay, I do have this. See here. 1 minute. Right, okay, here. Do I have it running? I haven't had our so there's my place. But back to machine. A minute. Sorry about this. To be able to shoot. What's that? Go here first. Let me go jump back to the correct screen. I did, yeah. I'm having a little issue here. I did lose audio. 1 minute. Okay, can you hear me now? Drop connection. Sorry about that. Okay, let me share again. I'll share again. Again, just basically find your first LTE. Can you hear me now? No?
Yes.
Okay. Sorry about technical difficulties with this. Get these hammered out for next meetings. Visitations. Again, going through here. I have this keys already set up. And now you can see my Linux machine. We'll just go to the keyboard. Alright. We have all the packages else we don't do that, but the device right there, so also do have a smart SIM card in there, which I can show you like that.
This is really hard to read.
I know. That's what I'm zooming in. A minute. Zoom. Let's get the text size a little bigger. Is this better?
Yeah. Ish.
Okay. Yeah. On the size. Let me get the. So what have you? But okay. So I do have this. So what we're going to do first is show the reading from the SIM card, which I already have in there. Which is under the BISIM. We don't need to program, but we do need to read it. Easier since I already have it there. Activated. See here, yeah. See, there is a SIM card in the reader. Basic information for that. And these, again, as I mentioned earlier, very similar to your security smart cards or CACs on federal space. Now the installation's done, so we have that on. Again, it's a great tutorial. Eventually, do want to get to the containerization of this application, but basically start from the top down, do things manually, best flow, work your way up. Get the service started now. Was pretty much abrupted because of the power cut, so 1 minute.
So what was on the smart card that you were communicating with? Is that the 5G interface?
That is the subscriber information, actually. We go back to that. So it's just very basic mock data. So you have the IMSI, subscriber information, code number, card ID. And again, these are just play mock SIM cards, so which I had to order from a supplier in Germany. It's actually one of the main contributors for this Open5GS project. But if you do have a CAC reader for basically the same device to read these, so let me get the 5GS service going. I do have it installed. Let's see. I do have it going. Let me check that it's going. It is still going. Okay. I thought I had the processor. So basically, I'm still using the basic admin 1423, and what this basic step is for 1423. Why I showed you the card is because this is where you actually configure the card for this radio. That platform. 1 minute. I'm sorry if I'm. What's going on here? We did lose the page. I've lost my subscribers. Okay. But this is again where you take the smart card information in. IMSI. Program that in. So we're going to take in number. In terms of security and key management, this is a learning experience just in itself. We have the keys IMSI saved. There we go. We have to cut. Now we have that smart card authenticated with the 5G core network. So another thing I've been looking for is using one of the spare lots. I haven't trying to find down a 5G WAN module. Can work with the smart card and use that to connect to the Software-defined radio I have. Let's go back to which I've configured. USRBB 210. Just finding this equipment, first of all, both for a reasonable price. And again, this is a second-hand unit, an older version of it, so kind of cross your fingers, hope it works actually correctly. But yeah, these do go for around $2,000 new. And that is from Emerson, but yeah. What I did was basically shopping list for this lab was what was mentioned in right up here. It's Intel NUC mini PC. You could also get their options are the HP minis, Dell minis. They're great for home lab projects like this. Setting up your Proxima cluster, etc. They don't take up much space. It's like a blob of electricity, especially in Texas. Dallas and Houston have kind of fluctuating energy rates and get pretty pricey at times. Energy, so yeah. So we have the smart card and the service up running. Should do that. Where I am right now is actually, like I said, getting the actual device authenticate to it. Another device I've been supports Galaxy phone. It's 22 I have laying around. It's a backup, but I have yet where I'm stuck right now is yet to get, like I said, a device actually connected to radio. But if anyone has questions?
Oh yeah, we were asking for the link to your
The links.
Yeah, so that way we can.
I'll put that in the Meetup. On the Meetup page, definitely afterwards. Yeah.
Oh, okay, because it would be easier to read on my own screen.
Okay. I don't understand. Yeah. Yeah. Actually, bring those up. Presentation. Here is the tutorial. As well as linked to the Open5GS project. My webpage set up. I want to read through those. Yeah.
Much easier to follow now.
Yeah, I know it's quite a bit too live. I just again showed you where I am right now. Also configuring it to network. I did, as mentioned with this project, setting up OPNSense, another good thing to look into. You're into learning more about networking. This is also a learning curve. 5GS. It's what I have right behind the Intel mini PC. Intel NUC. That's running the software-defined radio in Open5GS, as well as now the entire home network. You're coming from, like I said, software network background. Script with the script platform to learn networking. Did use OpenWRT on for ACM Linksys, which kind of knocked out. Yeah. With this, yeah. And this is again the Protectli. Or you could just do any kind of, like I said, to a network interface card, port, any PC or device can run this. This is for x86 Intel, so what I got was Protectli. Got the logs thing around here. I do actually. Where's the stuff? Here. Play Vault, FW4C, or one of the newer ones will work for that. So yeah, it's lots learning, but yeah. And Jonathan, you have a question?
Yeah, I'm just curious. Is this compatible with like the freepbx.org on communicating with the open or the 5G radio, or is that a good question and no one knows?
Got that. It's not USRP. National Instruments now. Emerson. Trying to ask if the free PBX.
Yeah, connecting, because you can. Granted, I know a little bit of the open source 5G core network before this call, but it was like you already went through like 10 times more information than I knew. I didn't know if there's a way to set up free PBX to monitor like desktop calls, and then on that same network have also cell phones to connect to that sort of an internal PBX type environment, if that makes sense at all.
Call handling, that's a good question, because what I've been going through right now is mostly the IP network handling and authentication.
Okay, no,
securely, but I suppose so PBX, of course, that's for handling the calls themselves. Yeah.
Right.
Well, since this is basic, if you did everything's handled over IP, I suppose, yeah. As long as you don't rely on a static IP address for each individual endpoint or phone. Phones are connecting to a central server. Could use this over. I mean, this year.
You understand? It's just a question. I'm not looking for an answer. It's just if anyone tried and said no, will not. If definitely won't work, or use research.
Again, that's more research for me, because as I said, I've been focusing more on the IP aspect of the networking, not the voice. But yeah, since this is again your standard IP network, suppose they should. As long as, like I said, I'm not sure. I haven't really used free PBX, so as long as free PBX doesn't require each phone device to have its own static IP address. Still, even with a private 5G core, still might be possible. It'd be complicated though. And yes, Mister.
How much logging is it possible to gain with traffic that we're seeing from the network side? Is it possible to add an additional layer to stream network data?
Of course.
Okay. So at the 5G level.
Yes, there's actually quite a bit of logging. If you go through the documentation, let me go.
Yeah. So and at the same time though, is it possible to layer that with a network device that's able to stream those logs?
Yeah, there's actually one of these tutorials, monitoring metrics with Prometheus, so you get the, like I said, CPU, signal metrics, and let's see. There are plenty of tutorials on this right here. Let me share those.
Yeah, that'd be good. Can you put that in chat, please?
I'm doing that. Yeah.
What I'm trying to conceptualize is like visually like see what those logs look like, so that I can layer on top of that another device that is able to add access control methods to it, so that because like if you're on your home network, you know, everything is fine, so you connect to your Wi-Fi and all that. But like with 5G, how do you layer like access control and say that this is all the areas that you're able to go and all that? It's pretty much just wide open, right, to wherever your LTE or your 5G that you're connected to at that network level.
Yeah, that would be. Suppose at that point, if access control for external services outside the 5G network, that's where it's mentioned using OpenPNSense or.
Yeah, love that. Would love to see where we can go with that afterwards, and how we can apply some sort of like network firewalling, you know, to be able to stream those logs.
Yeah, again, I already have this going. That's where I.
Yeah, where are you going with this?
Yeah, I already have OPNSense running on a network basic.
Okay.
Yeah. Create a special. I mean, work interface for this, and because if you're talking about basic authentication to network, that's where, as I showed you, 5G core comes in hand. It has, like I said, who has access subscribers for the network, as well as getting control handling the radio communication from to the devices. Then of course you need an upstream device if you want to handle, like I said, what kind of services that devices can access on the WAN side or upstream into LAN.
So could you again list out all the network devices that you are hosting and what they are? I'm curious what those components are.
Yeah. About the root core of the network.
Not just the software side. I'm curious what the hardware looks like.
This is the other device, as I mentioned in the post website. We're replacing that open with a OPNSense. Let me get the model number of that. This is an older version of that, but you could basically go on. For the Protectli live volts appliances. I went with a older 4G. It's basically the older one here, so similar to this one, VP4230. Signal I have is W4C, but if you have multiple devices on the network, or if you want to use this for your home network as well, do recommend getting at least a 4-port, or maybe if you go overboard, you could get 6-port, but at least 4-port versions. But these are basically our Chinese x86 Intel mini PC running either a Core 2 Duo or Celeron. And yes, sir.
Yeah, another question. Sorry. How do you, with this implementation, use it while still adhering to like the major carriers restrictions, and ensure that your device is still functional with like a Verizon, AT&T, or T-Mobile? Like they have kind of like their own restrictions. So how do you make yours
You have to
your device still functional?
with basically only use the open unlicensed bands. So let's look up the unlicensed bands. There is a bit of overlap. We found at 900 megahertz. So let's go. PDF with the. And of course, you have to consider the 5G bands too. You have to basically do a cross-reference, find the ones that you're allowed to use. Idea here for the 5G and our frequency bands. Let me pull up the one. Yeah, it was under the. And again, cross-reference with the CC unlicensed bands. Such as you. Bit of coverage on that. 6 megahertz. 6 gigahertz, which usually the higher the frequency, the less interference it will cause because you have shorter range. But if you have the portable radio right next to the device you're connected to, or it's your phone, laptop, should be a big problem.
Thank you. And could you, for like people that just need fresheners on this topic, could you recommend any kind of books to get or small projects to get going, or what are some highlights?
Again, good one right here. Just going through these tutorials. I know it's kind of. This depends on the country you are. In the U.S., like I said, you have the FCC regulations. You have to make sure you're using an unlicensed band. Let me pull those lists up real quick. There we go. So such as, and again cross-referencing GF here. So what I found was, correctly, it was 700. The higher frequency bands, but there's quite a few of them in various places.
Another question, Joshua,
Yeah.
I'm curious.
Yeah.
Where do you see 5G going in the coming future, 2026 and beyond?
Again, it's just pretty much self-defined networking implementation for net. Okay, so. And the cores, again, 5G is basically built off of the old legacy LTE 4G core, which also legacy. So what you want to focus is on mobile network cores, basically. Future course, 60 cores eventually. But again, how things are going, technology, networking-wise, SDN as itself is basically where everything's heading.
I've heard software-defined networking for a very long time now.
Yeah.
It's been
Again,
Yeah.
I have since 3G, then 4G. Yeah. Well, any other questions? I can't.
No, I think this is great. Thank you.
Yeah, I'm gonna post links in the chat, and also again write down the. Forgot to because I had to take a break from this due to work related, so family emergency earlier this year. So now getting back with this project. To have frequency I could use written down. Forgot that. Put that in the meetup notes as well. Another thing you can do with SDR radio, working with our Maria project, is get a tiny SA. You can use this. It's not the most accurate spectrum analyzer, but it's very portable, not too pricey, and very affordable. So it's only This again, you can measure noise, basically ambient noise. Things are being transmitted on a specific frequency. Yeah. Now closing. I'll put the link to this in Meetup page as well. Come on, let me copy. Firefox won't let me copy. Okay. That's all I have right now. If anyone else has any final closing questions.
No, I just want to say thank you.
Yeah. Like I said, these links know about the frequencies that you can use in the US, and as well as again for staying at the back end, OPNSense, as well as devices, Protectli, or I'll post all the links in the Meetup page reference, and also the recording of this presentation if you want to go back to it. That's all. Again, that's all I have today. Thanks for joining.
Yeah, thanks for putting this together.
Yeah, I'll do follow-ups later on as time comes. But yeah, basically next one, hope to
Thank
go
you.
more over various components of 5G core, which go through those. They can get pretty complex. If you're looking at a quick start, here's a basic diagram.
What do you think of this book? I was just looking at it on Amazon. Sorry about that, links, Large. Just want a quick refresher on 5G core.
Yeah, let's check it.
I'm sure like the first couple pages are going to be hard to keep going, but
Yeah, I'll go through it. Also share the link
Yeah.
if it's good.
yeah, thought I'd share.
Yeah. Yeah, thank you. Okay. Have a good evening, and out. Yeah.